what we're going to do is take a look at graphing ellipses, which is one of the four conic sections. And if you took your cone, if you took one of the naps, either the upper or lower, and cut it from side to side, if you held up one of those pieces, you would be looking at an ellipse. If you think of like a waffle cone, to the very top of a waffle cone, that is also in the shape of an ellipse. So here we have two ellipses. One has a major axis that is horizontal, and the other has a major axis that is vertical. The major axis is always the longer of the two, and the minor axis is always the smaller of the two. Right? And the way to tell if you're going to graph these, if you know it's going to be major or minor, the value with the larger denominator. So if your a value is larger and it's with the x's, it's going to have more of a pull on your x's, so it's going to be a horizontal major axis. Likewise, with a vertical major axis, your denominator of your y values is going to be larger. Just keep in mind, if they were the same denominators, you would actually have a circle. We'd have an equal pull in every direction. Right? To get some vocabulary, we have a vertex and a vertex. Those are always the endpoints where your major axis touches the edge of your ellipse. The center is right in the middle. And we have two foci, which are points that actually help us graph the ellipse. And one thing that you have to keep in mind when we graph these, the distance from the focus to the center, and the center to the endpoint of the minor axis, this hypotenuse is actually the same distance as the distance from the center to one of the vertices. Alright, so that's very important. If you're thinking Pythagorean theorem, we have an a b, and a c. A squared plus b squared equals c squared, or your small side squared plus small side squared equals your large side squared. Alright, so suppose we were to graph x minus 1 squared divided by 4 plus y squared divided by 9 equals 1. The first thing you want to do is identify the center. And the center is always what makes this 0 of your x values. If you plug it in a 1, it would make it 0. And since my y squared is by itself, that value is going to be 0. And we'll go ahead and plot that point 1, 0. That's going to be the center of the ellipse. Now we want to find the distance from the center to the x values, the endpoints of the x values. And this is very similar to when you graph circles. You take the square root of the denominator with the x values. The square root of 4 is 2. So from the center, I'm going to go 2 units to the right and 2 units to the left. And to get this distance from the center to the y values, we're going to do the same thing. Take the square root of 9, which is 3, and from the center, I'm going to go up 3, and I'm going to go down 3. And now you have the outline of your ellipse. So go ahead and draw that. Once you've drawn your ellipse, you can see that the major axis, which is the longer of the two, is definitely vertical. I mean, you could actually see that from just looking at the equation. The 9 is greater than the 4. And the vertices are these endpoints. So 1, 3, and 1, negative 3. Right. The endpoints of the minor axis are going to be negative 1, 0, and 3, 0. Right. From there, all we're left to do is find the foci, and the foci, there's, it's tough to see where they are, but they're somewhere in between the center and the vertex on both sides. And just keep in mind, I'm just going to guess that it's somewhere around here, that this triangle formed, right? The hypotenuse of this triangle is the same as the distance from the center to either vertex. So if I drew that triangle down here, make it a little bit bigger, we know that this distance is 2. We know the distance of the hypotenuse, which is from the center to a vertex, is 3. So we can find the distance from the center to the focus by using Pythagorean theorem. We'll call this b. We know that a squared plus b squared equals c squared. And solve this for b. Alright, so if we solved 4 plus b squared equals 9, we'd get b is equal to 5, the square root of 5. You actually get plus or minus the square root of 5, but since it's a distance, we only use the positive. So b equals the square root of 5. That represents this distance. So if we were to write the ordered pairs of the foci, we'd write it as our center is at 1, 0, my x value is going to stay the same for both of those. My y value is going to change though. It's going to go up square root of 5, and it's also going to go down the square root of 5 from 0. So just plus or minus the square root of 5. Alright, and you're done. Alright, if we were to graph, now this is general form, 25x squared plus 4y squared plus 50x minus 24y minus 39 equals 0. What we have to do is complete the square for the x terms and the y terms. So we want to group those together. And if you're looking at this, the way we know it's going to be an ellipse is because both my 25 and my 4, the coefficients of my squared terms, are both positive, and they are different. They are different values. So what we're going to do is group the x terms and the y terms and move that constant, negative 39, to the right side. Alright, so what I've done is I grouped together the x terms and the y terms, and I moved the 39 over. And then, in order to complete the square, we have to have a leading coefficient of a positive 1. So I factored out a 25 from my x values. And then I did the same for my y values. I factored out a 4. And what we're going to do now is we're going to complete these squares. So I need two numbers that multiply to give me, I need to take the half of 2 and then square it. Half of 2 is 1, 1 squared is 1. Alright, and we'll do the same thing over here. Half of negative 6 is negative 3. Negative 3 squared is 9. Now when I add these values to the other side, you're not going to add 1 and 9, because I actually added 25 over here. If you take 25 and distribute it, you'll get a positive 25. So you have 25 extra. And the same thing over here. 4 times 9 is 36. Right. So let's factor these, clean these up, and clean up the right side, and it should look something similar to the graph, to the equation we had before. Alright, so I factored these, and we have 25 times x plus 1 squared plus 4 times y minus 3 squared equals 100. Now, when you graph ellipses, this must be a 1. So to get 100 to a 1, we're going to have to divide it by 100 and do the same to the entire left side. Alright, so when you divide by 100, 25 and 100 reduce to 1/4, so we have x plus 1 squared over 4, and then we have plus 4 over 100 reduces to 1/25, so we have y minus 3 squared divided by 25 equals 1. And from here we can get the center. We know the center is at negative 1, 3. Alright, we'll go ahead and plot that. And the distance from the center to the x values, the square root of 4 is going to be 2. And the square root of 25 is going to be 5. So let's go ahead and plot these and draw an ellipse around these points. Right, so I plotted the center, and then I went out 2 on the x values in each direction. I went up 5 in each direction for the y values. And from this you can see that the major axis is indeed vertical. Right, and from here you can see in the equation that my y values had a larger denominator. The vertices are the endpoints of the major axis. So they are at negative 1, 8 and negative 1, negative 2. And the endpoints of the minor axis are at negative 3, 3 and 1, 3. And what we have to do is find the distance from the center to each of the foci. And to do that, remember, I'm not sure where the foci are, but they're somewhere in here. So if I were to draw a triangle, a right triangle, I know that this distance is 2. I don't know what this is, and I know that the hypotenuse, which is the same as the distance from the center to either vertex, that is 5. All right, so solve this right triangle, solve this for b, and that'll get you the distance from the center to each focus. All right, so we get b is equal to the square root of 21. I took 2 squared plus b squared equals 5 squared. 25 minus 4 is 21. Take the square root of that. And now for the foci, if you look at the center, which was at negative 1, 3, my x value is not going to change, so that's going to be at negative 1 again. And then from 3, I'm going plus the square root of 1 minus the square root of 1 to get those 2 points. So 3 plus or minus the square root of 21. And keep in mind, this is 2 points. Negative 1, 3 plus the square root of 21, and negative 1, 3 minus the square root of 21.